hello everyone, again. This time I'm not giving a quiz, so please don't get your hopes up. This time it's a science slam. And yeah, it's about medicine, because this is a special event about X-rays, and usually people have in mind first, when they think about X-rays, that it's going to the doctor. And usually it's not a very good occasion, because you broke some bones, or you suspect that you broke some bones. Hopefully not other people's bones. And I just have 5 minutes to tell you a bit about that. Okay, so first of all, I want to pick you up where you just were left, which is something about astronomy. So on the left side, you see the Large Magellanic Cloud in the X-rays photographed by a Rosetta. So we have an X-ray source on the left, and then some camera that tries to get a photo. And if you go to the doctor, what actually happens is they have exact the same. They have a source of X-rays, then they have you in the middle, and then on the other side, some camera that makes a picture of X-rays traveling through your body. And the picture then would look like this, obviously. So you now say that my comparison is a bit bad, because that's very unrealistic that this would happen like this, and I agree, and I'm sorry. I know that in astronomy the usual X-ray energies are only up to 20 kiloelectron volt, and yes, in medicine we use 25 and above. So I'm very sorry that the comparison is a bit lacking here. So in medicine, you use 25 to 30 kiloelectron volts for mammography, so for taking an X-ray of soft tissues of the breast, and 30 kiloelectron volts up to 120 kiloelectron volts, so much higher energy than what we typically see in the universe, is then used to actually send light rays through your body, and then we just look at how many X-rays will actually reach the detector. So I just talked about all these energies, high energies, ionizing energies, and you probably heard that this is not really a good thing to have X-rays taken very often. So the next minute I spent on telling you, okay, how safe is this really? Because when you take an ultrasound, no doctor ever left the room. But when you do an X-ray, you get preparations, and they tell you to hold still, and then they leave the room, and then they press the button. So naturally, during a year, you get 2.4 millisievert, which is the unit of ionizing radiation. 2.4 millisievert you get ionizing radiation per year naturally. On top on that, on average, 1.5 millisievert for any medical purposes. That could be taking an X-ray or taking some pills to get some contrast for, all these things. And you may heard that you can use bananas as an equivalent doses. And going back to that, 2.4 millisievert is 24,000 bananas. Just that you have a picture in your mind. During the year, you're exposed to 24,000 bananas. And if you eat as many on top of that, then you raise this level of ionizing radiation that can actually change the genes in your body. And this is the very key thing of evolution. So without the ionizing radiation that naturally occurs in our surroundings, evolution wouldn't have happened like that, probably way slower, because there are these copy-paste errors as soon as a new cell is created, but they're not that common than just having some ionizing photon, high-energy photon, changing something in your genes, and usually not for the better. So evolution, if you believe in it, and I hope you do, is a very efficient process during millions of years, but it has a very high failure rate, so probably you don't want to be the one person who develops right now the third arm that we all wanted to get our household done. Yeah, so ionizing radiation itself is a challenge. Our body can handle it quite well. We have mechanisms that always check, are the genes still the same? No, we got to repair it. And this is constantly happening in our body. But eventually, this will fail. And then you get a mutation, and then hopefully it's not a bad one. So the less ionizing radiation you're exposed to, the better. And this is the reason why doctors try to keep X-ray scans to a minimum. And as soon as you go up to 50 millisieverts, so 20 times the amount of your natural radiation, you get into a zone where it's a bit dangerous. You have to take 10 flights to the US and back, and then you get into this range. And a typical X-ray scan will just add 0.01 millisievert to that. Okay, so it's quite safe. But if you're working there, you should take some precautions, because if you get X-rays every day, it can be quite bothersome. And the next and the last question for the short amount of time I have with you is, why me, an astronomer, is telling you something about medicine? So there are 3 reasons that I came up with when I asked myself these questions. Reason number 1, I survived a bachelor in physics. That means actually learning the very basics of what is radiation, what does it mean when the energies are high, and I even did some X-ray scans, but with crystals, not really human bodies, because we physicists are scared of other humans. Second reason, nobody else volunteered. And third reason, which is hopefully a good reason, because I think it's a good reason, is I'm working on dark matter simulations. And I have a picture here for you. This is a typical dark matter simulation where we track all the dark matter particles in a simulation cube, and we let it evolve and evolve and evolve, and we suspect it would look like you see on the picture now. We have clumps, we have filaments. It's a very beautiful structure. It's very clear. Yeah? And now we do observations of that. And I'm in the gravitational lensing group, so it shows a picture of gravitational lensing. It's hard work, but, I like simulations. And now we get back to medicine. This is an X-ray scan. Very clear, very nice. Even a layman like me can actually see something by having a first glance. So this is a rib cage. You see the spine, and this grayish triangular thing is the heart. Now the same thing with an ultrasound. It's so hard, I ask a doctor. It's a boy. It could be anything, and if you or your wife or your sister or whoever was ever pregnant and you visited one of these ultrasound scans and they tell you, here you see the arm, I was always like, cool. It's moving. Yeah. So I really like, it really appeals to me that X-ray scans are something that really anybody can have a look at and see something immediately. You should always study to actually give professional comments, but to actually prove to you that it's kind of easy. A couple of months ago, a friend of mine on WhatsApp told me why he's not coming to something I organized, and he just sent me this. And then I had a look, I, professional astronomer, had a look, and I immediately recognized there is something wrong. This is the collarbone. I hope you saw it too. It was broken. Riding a bike is very, very dangerous, especially if you go to the mountainside and try to jump. And a couple of months later, and now a couple of weeks later, he showed me this. He got a caterpillar, actually fixing his bone. He's very happy alive now. And I guess some people even know him, but I don't give names here. And with this, I hope you learned something about the difference between X-ray astronomy, which is measuring some light, and X-ray in medicine, which is measuring the shadow from this light. That it's safe in principle, but you shouldn't overdo it. Always ask your doctor, is this really necessary? And third, you know why I like X-ray scans. Because of caterpillars.